Here we're going to complete step numbers 2, 3, and 4. We have our normal curve. We have shaded the critical region on the left, and we have placed our critical value on the left side of 0, because this is a normal curve and this is a number line. 0 right is in the middle. If it was a right tail, then we'd have to drop the negative sign. Okay, so let's check what step number 5. What is step number 5 say? Step number 5 is saying to calculate the test statistic. So here's the formula for the test statistic. It's a z-test statistic. Remember we said on the curve, there are 2 important numbers when you're talking about the critical value approach or the rejection region approach, the classical approach. There must be 2 important numbers on that curve. One is already there. The critical value is there. Okay. The other number will be the test statistic. Okay. That's step number 5. The other number is test statistics, which is step number 5. Okay. So here's the formula for the test statistic. And you need the sample mean, you need the population mean, you need the standard deviation, and you need the sample size. 4 numbers. These 4 numbers will be provided. Here they are. The sample mean, the standard deviation, the sample size is 50, and the population mean is 8. So these 4 numbers will be provided so that you can calculate the test statistic, okay, using this formula, okay, and that is step number 5. So the z-test statistic, we go to insert, we go to equations, minimize this a little bit. Okay, minimize a little bit again. So z underscore TST, you can put test statistic for TST, test statistic. When you put a little c, doesn't matter, is equal to, it's a fraction benefit. X bar, the sample statistic is 6.9 minus mu, the 8. That was what was proposed in the hypothesis. This is all divided by sigma, the standard deviation. That's another symbol for standard deviation, the Greek symbol, divided by, that's 1.89 coming there, 1.89. The square root of the sample size. Square root of 50. A sample of 50 was taken to test that hypothesis in that example. And this will give us a test statistic. So we can use that test statistics and go back to the curve in order for us to make a decision whether to reject or not to reject the null. Okay, so let's go to calculate the test statistic. So we have a fraction, and be skillful in your calculator. This can be done one time. There's a fraction. Above the fraction, you have 6.9 minus 8. Below the fraction, you've got another fraction. And you have 1.89 divided by the square root of 50. Okay, so you can just click equal, and that gives us negative 4.12. Negative 4.12. 2 decimal places suffice. Okay, so that's step number 5. And let's put step number 5 and 6, because step number 6 is to use that test statistic and plot it on the curve. Go back to the curve in order for you to be able to make a decision and then to conclude. So we have to go back to the curve. Remember, the critical value approach with that negative 4.12. Okay. Copy C, Control C, Control V. Okay. And we can put a negative 4.12 inside of this text box. All right. And to plot on the curve in order for us to either reject or not to reject the null hypothesis. So that will be step number 6 happening one time.